Hey everyone, welcome to our lesson on the sine, cosine, and tangent functions. Sine, cosine, and tangent are terms that are relationships that relate angles in a triangle to their sides in that triangle. And they will always follow these ratios here. Sine is always going to be the opposite over hypotenuse. Whatever angle you're looking at, it will be equal to the opposite side from that angle over the hypotenuse in that triangle. Cosine is going to be the adjacent side to that angle divided by hypotenuse. And tangent is going to be the two we haven't discussed, the opposite divided by the adjacent. So if you memorize these ratios, they will be very helpful for you finding missing angles and sides in your right triangles. Now, two special right triangles that we will come across a lot, so we'll discuss them here, are the 30-60-90 special right triangle and the 45-45-90 triangle. They have these special relationships, side relationships every time. The 30-60-90 has a ratio of 1 to root 3 to 2. That does not mean that the side lengths are always these lengths, 1 unit and root 3 and 2. It means that they have this relationship with each other. For instance, the adjacent side across from 30 is 1, the hypotenuse is 2. It means they have a 1 to 2 relationship. So whatever value is sitting there over on this side with 1, the hypotenuse should be double. So it's just more of a relationship, not an actual length there. Same thing for the 45-45-90. They have side length relationships of 1 to 1 to root 2. So basically anything that is sitting on the legs should be equal in a 45-45-90 triangle. That's because the angles are equal. The 45s match. So those are our special right triangles. So using special right triangles and those side length relationships, let's practice finding some of these trig values here. So the sine of 30, anytime you see a 30 or a 60, you want to go ahead and draw that special 30-60-90 triangle. And we can find whatever they're asking us for from that point. So let's say 30, 60, there's our 90, and we're going to label those side lengths, the relationship. So across from 30 was our 1, across from 60 was our root 3, hypotenuse is 2, across from 90 degrees. Sine is supposed to be the opposite over the hypotenuse. So from this location here, from this angle of 30, the opposite side and the hypotenuse across from the 90 is here. So if I take those values, sine of 30 is equal to that, 1/2, 1/2. Cosine of 45 is next, so we need to draw our other triangle, our 45-45-90 triangle. Got two angles of 45 here. This is our 90, and we want to draw that special right triangle with its side lengths. So we had 1, 1, and root 2 instead for that one. Recall, cosine ratio is supposed to be the adjacent over the hypotenuse. So you could pick any of the 45-degree angles here. And we need the adjacent side, which is the one attached to it. Here is 1, over hypotenuse, which is root 2. A lot of mathematicians don't like to leave radical signs in the denominator, so to fix that, anytime you end up with an answer like that, you can multiply both your numerator and denominator by that radical, and you can get the equivalent answer in a better looking form. So the radical will not be in the denominator. All right, one last one for practice, tangent of 60 degrees. I see 60 degrees, so I'm going to refer back to the 30-60-90 triangle once again. It doesn't really matter where you put your 30 and your 60 as long as you match those correct numbers for the side lengths that go with them. So 1, root 3, and 2. All right, tangent. Remember tangent. We haven't used that one yet. It is going to be opposite over adjacent. So find your 60 degrees. It's here. The side opposite of that is our root 3. And the side adjacent or attached to it is our 1. Root 3 divided by 1, which is just root 3. So there's some examples of practice with our special right triangles, finding these sine, cosine, and tangent values. All right, now let's talk about reference angles. When we're working on the unit circle, we're going to go out and find the angle that they're asking us to find first, called the angle of rotation. We're going to move in a counterclockwise motion until we get there. And then what we're going to do is we're going to form a right triangle with the x-axis, always with the x-axis. And the reference angle is going to be the angle that's formed by that angle of rotation and the x-axis, that inside angle there. So let's practice that. Let's say we would like to find the reference angle that matches 135 degrees. So what we're going to do is we're going to start at 0 degrees and move our way around the unit circle past 90. And we know that 135 is in the second quadrant here, somewhere past 90 but not quite to 180. So let's say it's around here. What we're going to do is once we find the quadrant it's in, we're going to form a right triangle with the x-axis. And the way we find this little reference angle here, which will be here, is we know that if we were to continue to the next line, that would be 180. So from 135, where we are, to 180 degrees is a difference of 45 degrees. So we know by subtraction that our little reference angle here is 45 degrees. So therefore we also know now that this triangle we have drawn is a 45, 45, 90 triangle. And we could then use, fill in our side lengths and continue to find other things if we needed to, such as the sine or cosine or tangent of that angle. So we are going to do that. We are going to practice. We're going to find the sine of 135 using that technique. So we just located it to be in the second quadrant, drew our triangle. We found out the difference between 180 and 135 is 45. So we're going to fill that in, and we're going to fill in the rest of our triangle here, the angles and side lengths. So 45, 45, 90 triangles have 1 on the legs and root 2 on the hypotenuse. Now, when you're on the unit circle, or on a coordinate grid here, you want to make sure you get the right signs that go with your side length values, and this one here is going to have to be negative since we are left in the second quadrant. Go ahead and list the signs here. First quadrant, everything's going to be positive. If you remember graphing points, right and up is both positive. Second is a negative and a positive. We went left 1 and up 1. Third is going to be both negative. And then fourth is going to be positive, negative. You can always write those signs out before you start if that helps you. All right, our goal here was to find sine of this angle. So we're just going to find the side length values that we need to find that. So sine is opposite, we'll abbreviate, over hypotenuse. Let's find the opposite from this 45 degree angle, which is, that's the opposite side. And the hypotenuse is 2. Remember how to fix this where the radical is in the denominator. Is to multiply the top and bottom by that root 2, and you will get this equivalent answer here, 2 over 2. We just found the sine of 135 degrees using a reference angle. Okay, another one for practice. Let's find a different trig function, the tangent of 210. So first we have to travel out until we get to 210 degrees. So we know that's past 180, but not quite to 270, so somewhere here in the third quadrant. And to find that exact inner reference angle here, when we form our triangle, we're going to see what the difference is between 180 and 210. If you subtract those, you're going to get 30 degrees. That is how far we are here. 10. Inside reference angle is 30 degrees. That means we have a 30, 60, 90 triangle. Now we can fill in the rest of the angles and the sides. So across from 30 needs to be our 1, across from 60 our root 3, and the hypotenuse 2. Fill in the sines next. Don't forget that. So we're in the third quadrant. Remember, both are negative. Both legs are negative there. Went left and down. All right, tangent. Remember the tangent ratio? That is supposed to be opposite over adjacent. Find the opposite and the adjacent in your triangle. So that is -1, this one here. -√3. So check it out. These two negatives are going to cancel each other, become positive. We've got 1/√3, but let's go ahead and fix that. Getting the radical out of the denominator by using that same approach of just multiplying numerator and denominator by √3. Get this equivalent answer. Awesome. So we are finished. We have concluded our lesson on the sine, cosine, and tangent functions.